Hello, this is Professor Iris Miano, Math 50 Pre-Statistics Day 1 lecture. Today we will be covering some review topics. The section is called R1 and it covers number sense and scaling. The reason why we want to have a good sense about numbers and scaling is so that we can adequately, accurately, and quickly interpret data through the form of graphical representation, collections of data in charts, and yeah, lots of other different representations that give us a lot of information all at once have to do with being able to interpret these things quickly. So that's what this section is pretty much all about in a nutshell. Let's go ahead and start by reading and interpreting paragraphs, which is what you see in the screen at the moment. Okay, so one of the ways that you can follow along with me in lecture videos, now you guys can do whatever you want with the materials that I provide to you, but my opinion is that it would be best if you watch the video with a blank copy, like if you have access to printing, that is, a blank copy of the lecture notes handout in front of you so you can mark it up along with me, and if you have questions as I'm going along, you can write your questions in the margin or in a notebook, whatever you want, and then we can discuss those questions. You can ask them during the class period. Okay, great. Let's go ahead and jump into this first example. It states that a housing committee is reviewing the cost of a two-bedroom apartment in Santa Monica, California. Data on the average rent can be found on the website rentcafe.com and is summarized in the table below where the rent is in dollars per month. So you'll notice that there's a table, and this is the table in question. I just wrote a little star next to it. There are two columns. There's the month and year column and the average rent column. And the average rent is in dollars. Okay, so there's no dollar sign there, but it is implied in the prompt that the units for the second column is in dollars. So we want to answer the following questions. All answers should be in complete sentences and include appropriate units. Yes. So one thing we want to strive for in this class when we write down our responses to just about every single question that we're given, every prompt, is to do so with full English language sentences with appropriate units, grammar, punctuation, all that good stuff. I know what you're thinking. This isn't an English class. You are correct, but we're still going to be using correct English as we go in writing our responses. So for number one, it says interpret the second line of the data or of the table in a sentence. Okay, so I'm going to be switching up the colors quite a bit here. Let's go ahead and use this light green color. The second line in the table. Now, second line is the second row underneath the, what do you call it? The headers, the column headers is not a row that counts as far as the data is concerned. This is the second line. Okay? So I'll just put a note there, second line. Okay, so it looks like in May 2015, the average rent in Santa Monica, California was $4,386. So that is what I will write down as my interpretation of the second line. The average rent in Santa Monica, California was $4,386 in May 2015. So notice that my grammar was sufficient. I have all the pertinent information and I wrote it in a complete sentence. It's really all that I'm asking for here and all that I'm looking for in your responses in general. Moving on to number two, which month and year had the highest average rent and what was that rent? Give your answer in a full sentence. Okay, so let's see. We're basically looking in the second column for the largest number that we see. So scanning, scanning, scanning. It looks like the largest number is $4,674, and it happens in May 2016. So we will then say the highest average rent occurred in May 2016 and was $4,674. Dunzo. That's all there is to it. Remember, folks, we're not trying to reinvent the wheel or do more than what's being asked. Just answer the question in a full, complete sentence and move on with your life. Let's do number 3 together. Between January 2015 and January 2016, did the average rent for 2-bedroom apartment in Santa Monica increase or decrease? By how much? Give your answer, of course, in a full sentence. Appropriate units. Yes. Let's go with this orange color next. Sure. All right. So we want January 2015. That's this one. And then January 2016. Right? That's what they're asking for. So it looks like it increased, right? So maybe I'll go back down and say, yes, it increased. Maybe I'll just circle that just to remind myself later. By how much? Well, in order to find that, we need to subtract. So 4,587 and subtract from it the 4,125. If you subtract the other way, you know, your borrowing is not going to work out. It's just going to be a big old mess. Of course, you can type this into your, appropriate calculator if you want to. Yeah, but I'm just going to do it by hand here. It's 2, 6, 462, right? Cool. Let's move down. The rent, or the average rent, increased by $462. Is that right? Yep, 462. From January 2015 to January 2016. Boom. Donezo on that one. Change the color for the next problem, and we are done with that one. Okay, number 4, between January 2016 and January 2017. Oh, looks like the same question, only different year span. Did the average rent go up or increase or decrease? How much? Okay, cool. Moving back over, now we want to look at this number versus this number. So, did it decrease or increase? It looks like it decreased this time. So let's go back down and circle the word decrease just to keep that in mind. How much did it decrease by? Well, let's again do some subtraction. We need the 4,587 in the minuend position this time. The minuend is a fancy way of saying the number on top when you subtract. Let's see, make sure I got all that correct. Yep, looks good. $402, it looks like. Fantastic. Decreased by $402. Average rent decreased by $402 from January 2016 to January 2017. Yeah, and you might have noticed that I'm not exhibiting the best handwriting. This is me writing with a stylus onto a screen. It can only be improved over time, so please accept my apologies for the decrepitness of my handwriting and understand that I will be improving it over the course of the semester to the best of my ability. Cool, cool, cool. So if anybody had any questions on that first page, go ahead and, like I said, jot them down as we go and ask them once we are back in the classroom situation, okay? The Zoom situation. Cool, let's move on. Now, one particular representation of a data set could come in the form of a number line. So I'm going to define this as a graphical representation of some data. Cool. So you will notice in the next example directly below the definition is there's a data set, a very small one. Student records the following exam scores for the 5 exams in a class. Cool. So it looks like this student has had a growth mindset over the course of the semester. Not doing so hot on the first exam, but look, every single exam afterward, improvement is being exhibited. Good for this student. Okay, let's go ahead and practice graphing these data points on the number line that's provided. So you might notice that there's a number line. It's a straight line trajectory with arrow points on either end, and there are tick marks that are labeled. And that's going to give us a sense of where to place these 5 data points that we were given. The first exam's data point is for a score of 45. Now 45 is going to be exactly halfway between the 40 and the 50. I mean, we're just going to approximate it to the best of our ability. With a dot, this teal dot represents the 45 score. And I'm going to go ahead and above the dot label it with the score of 45, excuse me, so that my intention is at least known as far as the location of the dot is concerned. Moving on to exam 2, 57. Now that should be somewhere between the 50 and the 60. Not exactly in the middle, but closer to the 60. So how about right there, I think is a good approximation for the 57. Again, labeling it leaves out all doubt of what the intention of that dot is. Moving on to exam 3, exactly 70. Go ahead and put a dot directly on top of that 70 tick mark. And since it's already labeled here, there's really no point in labeling it on top. That is clearly exactly 70 as far as the intention of that data points placement. Exam 4 is 73, so try and estimate about halfway between 70 and 80, but then go slightly to the left to indicate that you are a little bit less than 75, that is. Here's 73 approximately. And then lastly, our highest exam score was 89. Now that is practically on the 90, but not quite. So just make sure you are to the left slightly of the 90. Label it, of course. And we're good. Cool. Now, let's answer this question about this number line. What made this a good number line for this data? Well, you'll notice that all of the data points are spread out really well on the number line. So I'll say the number line range allowed for nice spread of the data. Anything else good about this number line? Yeah, I'll notice that the tick marks are equidistant physically, right? They all look like they're about, what, an inch apart or something like that, depending on the size of your screen. And all of the differences between the tick mark values are the same. They're all, you know, have a difference of 10, right? 40 to 50, difference of 10, 50 to 60, difference of 10, and so on and so forth. So the tick marks are equidistant. And the differences between the values are equal. So these features of a good number line are going to guide us in figuring out how to draw number lines for other data sets. So that's what we're going to cover right now in this little purple box, guidelines for scaling. The first thing that you want to do when you have a data set and you're reviewing it and you're figuring out how to draw a number line to capture all of the data in your data set is to note the largest and smallest values. These are going to determine what your largest and smallest tick marks should be. Your largest tick mark should be a little bit more than your largest data value, and your smallest tick mark should be a little bit less than your smallest data value. So then in part 2, you want to select a range of values for the number line that will encompass all of the data. The last thing you want to do is have the largest or smallest value of your range for your number line to be inappropriate for all of your data. You don't want to miss an opportunity to plot all of your data, I guess is what I'm saying. Alright, so number 3, it says the spacing between tick marks should be equidistant, which is just a fancy way of saying equally spaced out. The space between the tick marks should be equal, and the change in value between tick marks should be equal. Choose a difference between tick marks that will be consistent to cover the entire data set. Okay, yes, yes, yes. Number 4, after setting up the tick marks, plot your data. Using dots, right? Sure. And then of course labeling your graph with something that has to do with the data set itself. Just kind of, you know, take the data set and give it a name, basically. All right. Now we're going to have a specific example here in which we decide what an appropriate range would be. And we're going to go through those guideline steps one at a time in order to evaluate the best type of number line for this data set, and then we're going to create one. Here we go. Step 1, identify the smallest and largest values for the data set. So the smallest value, I'll go ahead and do in this like indigo color. That's going to be what? Scanning, scanning, scanning. Oh, July, or January, excuse me. January, not July. January is going to have the smallest value. It's 27. And the largest value is going to be July. Duh. Okay, because that's the, you know, hottest day of the month. Oh, sorry, I didn't read the example. It says, suppose you are working with a data set representing the average monthly temperature for a certain city over 6 months of a year. The average temperature is given in degrees Fahrenheit. Cool, cool, cool. So we already finished step 1 of the guidelines. Sorry, I got a little ahead of myself here. And let's go ahead and think about this span of values and determine which range would be a good choice for creating a number line to capture all of this data. So we're going to look at these ranges in this table, the ranges being 0 to 100, negative 100 to 100, 20 to 90, 20 to 80, and determine if it's a good choice, yes or no. That's what we'll put in the first blank column. And then of course we're going to explain ourselves, because it doesn't do us any good to be able to make claims without being able to justify them. Okay, that's just good advice in life as well as your math class. Alright, so looking at this first range from 0 to 100 and comparing that to the range of values, the smallest and the largest value here of 27 and 84, do we feel like that would be a good range of values for a number line plotting all this data? Well, I would say yes, it's okay. and it's like just okay. Yeah, just okay. I would recognize that it will spread out the data pretty nicely, but there's going to be extra bits of blank space on either side of the smallest and largest values that are plotting. So I'll say in my explanation, this range will span all the data and space it out well, but there will be blank space. So it's fine, but it's not the best choice out of the four that are available to us. Now looking at this next range from negative 100 to 100, wow. Think about everything that's happening from negative 100 to 0. In negative 100, technically up to 26, 27, it's going to be blank space. So half of the space is going to be blank. That's not a good representation for this data, and we'll just say that half of the number line will be blank or empty. Leave it at that. That's good enough reason for this to be not a good choice. Number line, sorry, let me just put the word line in there. Okay. Okay, moving on to the span from 20 to 90. Okay, take a look at this and compare it to the smallest and largest values. This looks great. This is going to be a tight but not too tight fit on the data set, because you'll notice that the smallest value, as far as the tick marks are concerned, the range is less than the smallest data point, and the largest value is more than the largest, right? So it's definitely going to fit everything, and there's not going to be a whole lot of blank space. Yes, and I'll put best choice in parentheses. Sorry, this range captures all the data. With little blank space. Love it. Okay. Now this last one, 20 to 80, do you guys see the problem with this? Yeah, that upper bound of 80 is not going to be able to include that largest data point. We can't have that. So that's going to be what makes this a no. Okay? And we could say as a little note, where's 84 go? Right? So we'll say the largest data point will not be able to be plotted. Won't be plotted. Cool. Now we'll have a chance to set up the number line. I'm going to go ahead and change my color to black for this and say, all right, let's see how many tick marks I'm going to need. 20 to 84. Now we decided 20 to 9 or 27 to 84. We decided 20 to 90 was going to be the appropriate range for the tick marks. So that means how many tick marks am I going to need if I go ahead and let's just say that maybe the tick mark should be spanned by 10 units. So that would be 20, 30, 40, 50, 60, 70, 80, 90. That's 8 tick marks. Okay, so go ahead and make 8 tick marks and try and make them as equidistant as you can on this number line provided. So it's 1, 2, 3, 4, 5, 6, 7, 8. That's not great. Let me try that one more time. And you know what? You might have to try it a few times to get it right, and that's okay. Try it again. 1, 2, 3, 4, 5, 6, 7, 8. I like that a little bit better. Okay, it's kind of pushed off to the other side now, but what have you. All right, so let's label them 20, 30, 40, 50, 60, 70, 80, and 90. Cool. Let's change the color to actually plot the points, and we'll plot them in, let's go lavender. That looks so cute. Okay, so the data was 27, then 44, then 71. So 27 we'll say is about here-ish. 27, 44, so halfway between 40 and 50, but slightly in, and by in I mean to the left. 44, 71, that's just going to be just a little bit above 70 right there. 71, and what was the next? 84, 68, 34. 84, halfway between but slightly to the left. 84, sorry I forgot already. 68 and 34. 68 will be about just maybe about there. 68, 34. 34, so halfway between 30 and 40, but slightly to the left. That's 34. Okay, let's label this graph. This is going to be, what was this representing again? Average temperature in degrees Fahrenheit. I'm going to label it underneath the graph. Average temperature in degrees Fahrenheit. I'll just put F for short. Okay, and that'll do it for that particular graph. Great. Moving on. Again, if you have questions, maybe jot them down as we go and ask them in class. Okay. Let's see. Next example. Below are 4 different proposed number line graphs for average monthly rent for a 2-bedroom apartment between January 2015 and May 2016, the period when average monthly rent was increasing. The data set on page 1. Okay. Remember that data set from like ages ago when we first started this video? We're going to revisit that data set in order to determine which of these plots would be a good fit for it. So we're going to look at each graph, discuss whether the graph represents the data set well and whether it uses good scaling techniques. If the number line is not a good representation, explain why. As always, use full sentences in your discussion. Great. Let's look at plot 1. Notice that plot 1's range is from 0 to 5,000. If you go all the way back to the first page and look at that chart, what was the range of values here? Well, the smallest value for average rent was 4,125 and the largest one was 4,674. So, 4,100, 4,600, more or less. If we go back to this thing right here, plot 1 is going to be terrible for that because all of the data is just going to be squished in this one little piece where I've circled it, right? So we'll say all of the data would be squished, technical term, into a small part of the number line. Leaving a bunch of empty space. Leaving a bunch of empty space. Empty space is no good. Oh, so for that reason I'll say plot 1, no. So I'm going to put a little X next to it, okay? Plot 2. Okay, 4125, 4386, all the way up to 5,000. Okay, so it seems like the range of values might be okay, but have you noticed that there's some really weird numbers on these tick marks? I wonder if the tick marks are having the same difference between them. So 4,386 minus 4,125, that has a difference of 261, whereas what's the difference between these numbers? 4463 minus 43686, rather. That's a difference of 77. Yikes. So right off the bat here, just finding the differences between these two different sets of tick marks, we notice that the differences between them are not equal. So that's enough to say, plot 2, you're bogus. We would say the differences in value are not equal among the tick marks. Okay, done deal. Boom. Plot 3, how are you looking? Well, you range from 0 to 500. Yikes. The smallest data point was $4,125, so none of the data points will be able to be graphed on this number line. So I'll state something to that effect. None of the data points can be graphed on this number line. Okay, cool. So by process of elimination, you might have noticed plot 4 is probably pretty good, you know, right? Hold on. Let me just look. Yeah, okay. Sorry, I just wanted to check one thing about the instructions. It didn't say that we needed to plot the data, it just said which plot would be good for it. So I'm looking at plot 4, and since none of the other plots were good fits, plot 4 is going to have to be a good fit, right? We could just kind of say yes, but let's explain why we think it would be a good fit. You may notice that the distances between tick marks is equidistant, right? Like equidistant physically, and then also the differences are all $100 differences. Differences. Okay. And then furthermore, it spans the data, right? So yeah, let's say something to the effect. The differences in tick marks in tick mark values are equal, and the range will capture all the data. With little overlap. That's also important as well. And by overlap, I guess I mean just a little bit of blank space on either end. Not very much at all. Cool. Great. Let me know if you have any questions on that when we talk again in class. Okay. So last problem, in which we have a very small data set, but it's going to be concerning two separate metro lines, right? We have the blue and expo lines for the metro passenger boardings in May 2016, 17, and 18. Notice that in the prompt it says 15, 16, 17. Sorry, that's a typo. Let me just go ahead and fix that. And I'll go ahead and change the color as well, just to mix it up a bit. Let's do this dark green. And let's answer this first question. It says, write a sentence to interpret the value 1.82 in the table. That's the one I've just circled in green. Include appropriate units. So it looks like 1.82 is the blue line, total boarding, in May 2017 was 1.82 million, right? Because it's in millions of passengers. People, right? What are passengers? They are people. That would be the appropriate unit. Now, if you want to put 1,820,000, like the actual like standard form of the number, rather than using the word million, by all means do so. It doesn't matter to me. This was just a stylistic choice that I took in writing down this number because it seemed to, flow nicely. That's all. Okay, number 2, and I'll go ahead and change the color just to mix it up again. Let's go this orange color. Are the total passenger blue line boardings increasing or decreasing over the time period given? Okay, so just focusing on blue line, that's this first row here that I'm underlining in this orange, light orange color. We go from 2.22 million, 1.082 million, 1.64. So it looks like we are decreasing, right, over the time period given. And that's all they're asking. They're saying, are they increasing or decreasing? So I'll just say the blue line boardings are decreasing over the time period given. Right? Just give it back to them with the same language that the prompt was given to you, and you'll be fine. And don't do any more work than what's being asked of you guys. It didn't ask you how much it was increasing or decreasing by, right? So don't bother with doing that subtraction. Just write the blue line boardings decreased over the time period given. Cool. Same question, but about the expo line. Let's go ahead and change the color to something wildly different like this purple. Okay, expo line. It looks like stuff is going up, right? So it's increasing. The expo line boardings increased over the time period given. Done deal. Moving on. For the blue line, I'm on number 4 now. Compute the difference between the number of boardings between May 2016 and May 2017. Do the same for the difference between May 2017 and May 2018. Include units in your response. Okay, so difference, that means subtract, right? Let me change my color here. Let's go brown. Why not? Okay. So 2016, 2017. 16, 17. Oh, and I'm sorry, are we on blue? Yeah, we're on blue line. Okay, so that'll be 2.22, 1.82 minus 0. Do some borrowing. Okay, so 0.40, but that's in millions of boardings, so that's going to be equivalent to 400,000 people. How do I know that? Because 0.4 times a million, right? If it's 0.4 million, that's the same as 400,000 people. All right, and we were just being asked to find a number and to put the appropriate units. That's why I'm not doing a full complete sentence for this one. All right, let's do 17 and 18 now for this differences. That'll be 1.82 minus 1.64. Okay, that'll be the following borrowing scheme. We've got 8. Okay, so 0.18 times a million, that'll be 180,000 people. Cool, cool, cool. In number 5, we'll reference these numbers, and the answer is the difference in the number of boardings increasing or decreasing. Explain in a full sentence. Is the difference in the number of boardings increasing or decreasing? Well, the difference in the number of boardings is either 400,000 people and later 180,000 people. Are we going from small to large or large to small? We're going from relatively large to small, so we are decreasing, right? Okay. Explain in a full sentence. So when we explain, we need to reference these numbers. And so we'll say, what are we doing? The blue line? The blue line, and I'm specifying this because if you read ahead to number 6, we're going to do the same thing but with the expo line. Boarding differences are decreasing from 400,000 people to 180,000 people. If you're trying to explain how it says here, explain, you really need to be giving some numbers. Okay, now let's do the same thing but for the expo line, and then we'll be done here. Okay, let me give you a fresh color. Let's go this electric blue. And okay, so May 2016-17, let's grab those numbers right here and we'll calculate them down below. So that'll be 1.62 minus 1.16, 1.62, 1.16, and that'll be, excuse me, 0.46, so that'll be 460,000 people. And then otherwise it was 1.62, need to be subtracted with 1.63, right? So I could tell that the difference there is going to be 10,000 people. Now why? Because it's 0.01, right? Is the difference. What's 0.01 times a million? It's 10,000. So definitely the boardings decreased. And we'll say by how, not by how much, but from what to what, okay? So really you can use the same wording that you used for number 5, only we're talking about the expo line and the numbers are different. So we'll say the expo line, boarding differences, decreased, or are decreasing, or decreased. I guess I changed my tense from one question to another, that's fine. From 460,000 people to 10,000 people. And there you have it, folks. First lecture, it's in the books. Good job. Thank you for your attention. Please give me your questions if you have any on this first lecture when we return to our Zoom meeting. Again, thank you so much.